Now it's recording, so we will get back to the slides. You can see my slides, right? Presentation, right?
Right.
In the chat is the Etherpad, so please you can join. Welcome to the meeting. Please be aware that this meeting is aligned with the notepad. The meeting materials, the Etherpad. This is the link. Please join the slide set adding to the materials, and we are as well in the Java room. And please volunteer for minute takers and sign the blue sheet that is there. This is the agenda for today. So we're going to go through the working group status, what's going to happen with role in the IETF 109, the progress of the RPCs given by Pascal, then the updates and capabilities by Raul, and then we are going to discuss about this REPL version 2 topics. Milestones, we update the milestone about Richard working groups are closed to next year, and of course we probably have to update the rest.
Ines?
Yes. Yes.
If that was the agenda bashing, I would like to bash on the agenda, if it's okay.
Yeah.
I would like to see if we can steal a little bit of time from the Report V2 topic to give it to me
Yes.
for the PDAO, because a lot of things happen on the PDAO, and I would like to steal like 20 to 30 minutes on this one.
No problem. We can.
So maybe we can pick some of them from turn-on, etc. But yes, if you don't mind.
Yes, no problem. Okay. About the milestones. Okay, we probably have to update some dates. We have updated the chapter milestone. So about the state of the active internet draft, AudioV Ripple, it's still in progress. We got a new version, but still some issues have to be handled there. Capability we have a new version, the projection we are going to discuss today. This modification is a work in progress. NVIDIA is in the RPC queue, and our priority is a new version, and we are looking for reviews for more places where we have a new version. Then the extension is the Shepherd documents in progress, triple observation active. Turn off is an ISG evaluation, and we have the update today and our lead as well. These are triple info we updated, and I have to update the diff documents, and when I update it, we can ship to Alvaro to continue the process, but I need to complete this diff. And then the food technologies is active, landing their information. Was presented last interim. Yes.
Can you maybe try to speak closer to the mic to overcome the noise? We know you have some noise issues, but Carsten saying he can't hear you.
Okay.
Can you try to speak a bit over the noise?
Thank you. Okay. So the information was presented in the last interim meeting, and now it's expired. We have open tickets in the GitHub about these DAO projection issues as well. These tickets are we presented today, and some other issues are in the track side. We have do a survey to know what the community think about meeting into the IETF 109. So from this result, most of the people like to have a meeting. Then the time slot will be one slot with 120 minutes. And we will have a meeting in December. These are the additional comments and suggestions. If we have in December, it should be after 8 December. And of course, we can talk on during the IETF about the REPL version topic. So, based on the survey, we will request a meeting before Friday to have a 120 minutes. Is that okay for you? Is that okay for you? Okay.
No objection.
No objection. Okay, we continue. with Pascal.
So thank you, Ines. Can you please move one slide? Oh, do you want me to move the slides? Okay, thank you. It's better if you do it. So this draft has been through pretty much all of the ESG review by now, but we have two discusses pretty much on the same subject by Martin and by Ben, and the discusses are about the mode of operation. You know that we define that for MOP 7, we would basically we would use the MOP extension, and that would be a REPL v2, and we'll discuss that a lot today. But it was very hard to say that correctly in a draft, because in the one hand, we appear to be changing RFC 6550 REPL, because REPL never said that there is a time bomb in how long the flags are available. And so there was nothing that said that for certain maps, those flags would be available, and for other maps, the flags would not be defined anymore. So just adding this capability to put a time bomb on the flags seemed to be an update to RFC 6550. And then how to express it, where there's a need to do some changes in IANA, etc. That wasn't clear. And it's not just this draft, it's also unaware leaf, and it's also use of REPL info. And as you know, use of REPL info is actually the first in line. It should, and we'll see the news today, but it should go back to RFC editor very soon. And basically, it is the one that should be being the first in line, that should be updating RFC 6550 to say that the flags are time bombed, and that the IANA tables should reflect that there is this time bomb. And so what I did in this draft, and what I did in unaware draft as well, unaware leaves as well, is to point on unaware and say, since that update, the flags are undefined for, you should not use the flag for a map of 7. So obviously, when a new implementation will implement a map of 7 or a map X, there will be a definition for the flags. But the problem was for an implementation written today. What should it be doing? Well, since we don't know what the flags will be for REPL v2, we just said, hey, you can't use flag to make a decision, but still you have to code something. So in the particular case of turn on RFC 8138, we said that if the map is 7, then and I copied the text here because it's very, very specific, and please look at it. Basically, the implementation must use the compression without checking a flag if the 6-loop and header compression applies to the link. And otherwise, it must not compress. If 6-loop does not apply to the link, obviously. So that's basically what we've reached discussing Alvaro, discussing with Michael. So we had those calls, and Ines, thank you. And so we reached that kind of decision. So you will see the same bottom line for use of REPL info and for unaware leaf, where since the flags are not available, there must be a decision. And so for each of the 3 drafts, we'll say, for MOP 7, what is the default behavior? So we pick the default behavior because we consider that this is a transition between a mode where the flag is kind of off, and a future world where the flag is on. So we decided that in this faraway future of MOPEX and REPL v2, the transition would be finished. So we used as default the other side of the transition. So for this particular case, compression is on. And that's pretty much it for this discussion. Oh, we have a message from Raoul. So how do you want to speak your question, or do you want me to?
Yeah. So I hope, so essentially it means that the turn-on draft is going to mandate RPL veto behavior anyways, right?
So the turn-on draft doesn't speak about RPL v2. It just says that MOP7 we don't know what happens in MOP7. That's what it says. So okay. It says if there is a RPL v2 and we want it to be backward compatible with an implementation that we do today with this draft, then RPL v2 has to have RFC 8138 on by default on 6LoWPAN links. So
okay,
it's really,
yeah.
In the future, you have to live with an implementation that you do today. So you want to know what an implementation of today does. So we specify what an implementation of today does. And this is basically, if map equals 7, then 8138 is on a 6LoWPAN. So in the future, when we write RPL v2, we will have to mandate 8138 in 6LoWPAN links, or will be non-compatible with the past. So there was another question?
Okay, yeah, okay, yeah. So yeah, that's fine. Thank you.
What was the other question?
Yeah, I think I'm the one with the other question. So that pretty much what you just explained was another question that Martin asked me separately, which is we're assuming here that 7 and whatever happens in the future is going to use compression and use and use whatever use of RPL info and unaware leaves and the other one, which I forgot.
About transitions.
Yeah. Right. So his question was basically the same thing that you just explained. You know, what happens if you guys change your mind, or what happens if in some extended MOP in the future, let's call it 10, or I don't know, whatever, the working group changes its mind. So my answer to him, and just to double check with you, is that at that time, if we ever get to, I don't know, something called MOP 10, either the nodes that are implementing this specification, turned on specification that don't understand MOP 10, but they understand 7, and they assume there's 7 and something else. We'll try to use compression.
They don't see 10, right?
Right. They only see 7, correct. So from their point of view, they're going to say, well, this looks like 7. I'm going to try and use compression on this link. If in 10, the working group said, no, we don't want to use compression anymore for whatever reason, then the nodes just won't be able to operate there.
Right. This node will be non-backward compatible. It will have to be retired from the network.
Right. And so what I told them is that by that time, what I hope is that this will happen so much in the future that we don't really have to worry about it right now.
Right. Now, if we improve 8138 and we maintain it backward compatible, then that should be okay. But yes, I mean, that's exactly correct. At least specifying something gives us that we know if we are backward compatible or not. So as long as we maintain those decisions, we are backward compatible. And the day we change this decision, we know we're not. And then we have to say, those old nodes need to be retired from the network because they cannot operate in that network. Yes, so any other question? Okay, so Ines, if you don't mind, let's move on to the other presentation. So that's unaware leave. So next slide, please. As opposed to the turn-on draft, unaware leave is just entering the IETF last call process. So for now, the review we had was Alvaro's review as the AD review for our own area. So thank you again, Alvaro. I mean, you're doing so much for us. But so I can only say thanks and thanks again. So the discussions that we had were not very much on the operation. It seems that the operation looked okay. It was more like definitions and terms. And what is a rule? Is it a host? Is it a plain IPv6 host? But no, because it needs to do this thing. Do we define the rule as being a host which can do the things that we place as requirements on the host in this draft? And so the answer to that is two things. First, the rule is already defined. It's defined in use of REPL info. And so it's a leaf, and the leaf means a host attached at the border of a REPL network. And it's REPL unaware, meaning that it doesn't speak 6550. And so by this definition, it doesn't mean there can be rules which will not be able to communicate in a REPL network. There will be. So we needed to clarify what additional requirements we add on the rule so that it can effectively operate by this specification. So it's not creating new standards because the standard is already there. It's at 505, but it's how you use it, what you place in this field, this field, this field. And that 505 was designed for this to happen. So that there was a clear, for instance, flag in the registration saying, hey, I want the router to give me routing services. So it's an abstract flag. It doesn't say it's for REPL because the host doesn't know it's REPL, but the flag says I want routing services. So we have a requirement on this draft that this particular interface in 8505 is implemented correctly, meaning that if the rule wants us to do REPL for him, then he has to set the flag as specified by 8505 for this case. So we don't want to change definition of rule. It's a leaf that is a host to a REPL network, and it's REPL unaware, meaning okay, it doesn't speak the RFC for REPL. But we also have had to explain clearly what the requirements were on the rule so as to operate with us. So the changes that were needed on this draft was to be more specific on when we use the term rule to make sure that it reflected the original definition. And there was also a lot of use of 6LN and 6LR. And 6LN and 6LR are defined for 6LoWPAN, and we are REPL, we are not 6LoWPAN. So why is it that we have to use that terminology? Well, that's because the other side of the interface, 8505, uses that terminology. And actually, we started reflecting that in use of REPL info for the routers which are at the border of the REPL network and that serves external destination. We already used the term 6LR. So in our terminology in this draft, I had to explain that by 6LN and 6LR, we meant hosts and routers which implement the function defined in 8505, not necessarily anything else, 6LoWPAN. I mean, it's just by 6LN, we mean just the 6LN functionality as described in 8505, excluding the rest of 6LoWPAN. It can be in, it can be out. But for us, for this specification, just means 8505 contribution. So clarified that. So now we know what a 6LN is in this document. So there again, we have the status of the REPL configuration option flag, the ODAC configuration option flag. So same resolution, pretty much now I duplicated completely the text between the two drafts, just changing, what the flags are and what the default value are for those flags. There was a final rewording that Alvaro asked me on the drafts. I made it in the GitHub. I'm just waiting for the next opportunity to publish because it's a very minor, I would say functionally speaking, doesn't change anything. So it's just clearer. So I thought let's not just publish +1 for that, unless Alvaro, you want me to.
Yes, why don't you go ahead? That way I see the final
okay.
stuff.
If you want me to publish that version as well, okay, I'll do that. So I have to do after this meeting to publish the new version of both documents just to incorporate that little change. And in this particular draft, so MOP7, since the flag is not there, and we're past the transition, the flag meaning the root is capable of proxying the EDAR. So when you get a DAO at the root, the root will do the EDA-REDAC exchange with the 6MBR on behalf of the host. So we save all the traversal of the network, which is one of the functions in this draft. Well, we expect that for REPL v2, the root must be capable of doing this. So it's on by default. And that's pretty much it. Any question on this draft? Maybe we can move on. Ines, do you mind? Okay, so I left those drawings. It's not to speak them for unaware, but they will be useful for the discussion on the rod projection, because we are also using tunnels, and I will explain why. Probably using those drawings. And also last time I was asked to publish them, so I thought, hey, what if I just keep them in these slides? So if people need them, they will know where to find them. Okay, so now we are going to the DAO projection draft. So this is still work in progress in the working group. It's progressing. Actually, there were many discussions on many fields. So just to remind people, this work is not benign. It's not a small piece of work. It's introducing a new routing paradigm into REPL. It's introducing SDN into REPL. And so it's kind of normal that to do a major addition to REPL like this, we have to define new formats, new messages, or new options. And it's also normal that we kind of hesitate whether we should do it this way or that way, etc. And that's when the discussions on the mailing list are so necessary. So I'm trying to trigger discussions on the mailing list, and I thank Raoul, Michael, etc. who are helping. More contribution is always appreciated. So one of the facts of the draft that it stood in the recent version is it got overly complicated. The reason for that is you could be operating in a main DODAG, which was storing mode or non-storing mode. And you could build storing mode and non-storing mode routes, P routes over it, projected routes over it. And actually, those projected routes could be injected in the main instance, or they could be traffic engineered paths that we call truck. So all these created a lot of combination, and add to that, what if the path between A and B goes over one track and then another track, or if one track is actually encapsulated in another track. All those things created so many cases, and it became unmanageable and just too much to implement and too many cases. So the question was, how can we make things simpler? And so also there was the case where you have an instance which has multiple routes, and so multiple DODAGs. And so do you want to build a path that goes across from one DODAG to the next DODAG across the frontier? And then which route would signal that? Because each route can only talk to the nodes in its own DODAG. So basically it was getting crazy. So we had to do some vocabulary kind of choices and make simplifications, like we did for having storing mode and non-storing mode in main REPL. We had to go the same path and say, let's get this too complex. So the first simplifying change that's proposed is, and actually I wrote it that way. I can roll back, but I wrote it that way in the version I published yesterday, that we have only one main instance. So we are playing within one main instance. You don't do P routes across instances, and you don't even do P routes across DODAGs. The only question left, and you'll see there are questions at the end, is whether the final hop, the node to which we deliver across this projected route tunnel, it's possible that it is actually on the next DODAG and still a neighbor to a node in this DODAG. And I tend to say, yes, that we should be able to do so we can continue on the other side. But we would not have hops across DODAGs, even if it's the same instance. So that's the first thing. So one route can actually control every node at every hop on this track. That makes things a lot simpler. So second simplification is the main instance itself. Do we want the main instance to be either storing or non-storing? The fact is the non-storing is, for the most thing, the mode which is mostly deployed out there. The other thing is we need topological information at the root or at the PCE to be able to push those PDAOs, to establish those routes. In non-storing mode, the DODAG is already known by the root. In storing mode, we would have had to add some signaling to tell the root about the DODAG. So saying that the main instance, the main DODAG, has to be non-storing makes our life a lot simpler. We don't have to signal the DODAG to the root, he already has it. The only thing that we need to signal is maybe additional siblings or possibilities for route computation at the PCE, but it's just advertising more siblings, not the whole structure of the DODAG. So that's a huge benefit on stake and non-storing. So basically, the second simplifying change that's proposed here is to make it so that only non-storing is usable for the main instance. Now, third thing, our main instance now is non-storing. Should we use PDAOs in the main instance, and what would that be for? Well, if you remember, when pretty much the first use case we ever had for PDAO was to say, hey, if this non-storing mode route down the DODAG is long, many hops, that means that routing header has many entries in it. Even if they're compressed, it's still a lot of space in my packet, and my frame is constrained. So how can I make it so that instead of doing strict source routing down the DODAG, we do some form of loose source routing down the DODAG? To enable loose source routing, it means that you have a routing state between the loose hops. And that was the first use of PDAO. Before we did those tracks and this traffic engineering and blah, it was initially just to shortcut between hops in a loose source routing header. And so to do that, if you use non-storing mode, you reinsert well, you don't even insert your caps for the steps that you're skipping, that you're saving. So if you do it only once in the network, or on the path, you actually save nothing. Even worse, you're adding more space actually in the frame, just to have this routing header between those two loose source hops. So it doesn't help really to use non-storing mode PDAO to complete loose source routing normal DAO. So the third simplification is to say, hey, when you're in the main DODAG and you just want to add routes to the main DODAG, then the only thing you may want to do is, and you can do, is storing mode PDAO. So now in the main DODAG, the result is the only possible combination is storing mode PDAO over non-storing mode routes, main DAG, meaning that it's really meant to enable loose source routing, and that's pretty much it. Now you can also do transversal with storing mode PDAO if you really want to. That's possible, but the main opportunity there is probably to establish to shorten the size of the routing header. If you want to establish transversal path, the idea is to use tracks. So that's those T paths, which are separate instances. Each track, as we call it in 6-dish and row, is its own local instance. Actually, I clarified that text in the recent version, but it was already there. Just try to rewrite it a little bit more clearly. But when we establish a route or kind of traffic engineering purpose to basically shortcut, avoid going through the common parent, blah, we use a geodag, which is rooted at the destination, and we call that thing a track. So I aligned, for the last discussion, the mailing list, I aligned the term track with what SigStation DAO defined. So we have a serial track, which is just a sequence of hops, or we have a complex track, which is like a geodag from a source to destination. Okay, so that's the track thing. Now, there is another simplification that we looked at, and now we enter the world where things are not yet very clear. It's how you can avoid loops. And basically, the way to create a loop is to have a route which is incomplete. I'm getting a message from, it's a proposal, Raul, right? So let's see what Raul tells us. It's cool to take the comments as we go. So
yeah, so Pascal, I'll let you finish and then come back. I just keeping my points ready. So yeah, it's
okay, but I see that it's a major change. Well, it's a major. We eliminate a lot of cases. So yes, it's a major change. So that's why I pointed out like
so Pascal, so if we in a way we are reverting back to version 1 of this draft, except for the track part and the multi-segment track parts, right?
Yes.
So we have version 1 plus multi-segment tracks in the document. Yes.
It's a way of saying it, but it's just for when we manipulate the main instance. Because what we wanted to do, those non-storing projected routes, they are completely there, but they are taken from the local instances of the destination. It's a lot easier to signal it this way than to try to add those routes to the main instance. And if you add those routes to the main instance, you start creating this risk of doing loops. And this is the one thing we did not want to create loops in the main instance. So we basically say, hey, we do only the easy game of basically PDAOs along to shorten the straight source route to make it loose. Now, the other thing that we do here, and that was one of your points earlier, is to avoid loops, right? So the prime is you have a track which doesn't go all the way to the destination, and that is not source routed. Then as you go through that track, and when you reach the end of that track, you have to route to the destination, but the track is finished. So how do you do that? If you go back through the main geodag, then you might go all the way up to a common parent, and then it would go down possibly to the ingress of the track, and now you're in a loop. So the hop by hop games, the storing mode projected route games can be very dangerous. It seems kind of easy to create loops with those things if we don't make them strict, like you give every hop, and you don't provide rules to ensure that when you put them one after the other, you don't end up in a loop. And this is the piece where we are not 100% clear still on the document. How do we avoid having a peer route and then another peer route and then another peer route, and we create loops? So right now, the draft says, if you use storing mode peer route, then you go strictly, so you put all the hops, so you don't lose, and you go all the way to the destination. If you do that, then you're sure you don't create loops. But if you do that, you cannot build complex tracks either, because complex tracks will have a sequence of segments. So right now, as the draft has it, this is too constrained. If we want to use storing mode PRs to complex tracks, then we have to make it. We have to allow, like, taking a packet off a track, off a segment, and put it in the next segment. So it's kind of non-fully understood and non-fully specified outside. So what is specified right now is a storing mode PR. So a segment is trigger by hop, and you cannot take from one segment and put in the next segment, meaning that you cannot do complex tracks with the draft as it stands. Obviously, we are not going to let's go with it. We need, or we need to accept that restriction. Otherwise, we need to figure out how we avoid loops. Next change. Well, that's what I was just discussing. When you take something off storing mode, projected route, you cannot put it in another, because if you put them back to back to back to get to the final destination, then you may have a loop, unless we specify how we avoid those loops. So the bottom line is, as written right now, you will see text which says when the egress of the track takes the packet off the track, so usually it's non-encapsulation, so it decapsulates, he has to do a local delivery, at least when it's a storing mode PR. Local delivery meaning either to its own stack or to a neighbor.
Oh,
but
okay.
not.
So Pascal, the way I understand this is the egress node. Yeah, so you've been very clear. So the egress node has to make the delivery, but how would that decision be made? What I'm trying to say is, how would I tell? I mean, it's a data plane operation. How would I tell my stack, which already is there, to make sure that that delivery is done locally? If not, how, on what basis will it not send it back to the root to and form a loop again?
So so we'll have slides for that.
Okay, sorry.
But basically, the packet has every indication that it's being forwarded on the track.
Okay.
Because we might do a lot more than just following a source route path as we are on the track. There could be dedicated time slots because we are doing determinism. So we need to know which flow we are in DetNet terms. And so for us, it's called the track. And so we need to specify what track we're in. And so it's in the packet. So the egress, when it receives the packet, it is the destination of that packet. In any fashion, the egress is the destination of the packet. Even if there was a source route, when the source route is completely exhausted, consumed, the destination in the end is the egress. So the egress gets this packet for local processing. Inside this packet, there might be, inside this encapsulation, there might be a packet to a neighbor. And that's when the features of RUL, etc., can be useful, the one that we just kept. But we may go back to that. But the bottom line is the track egress will be the end of that track. There will be an RPI which has the instance ID, which is the local instance ID that identifies this track. So based on that information, the egress knows it is the egress, and it knows which track that is. And so it can make the decision as he's the destination and decapsulates. That's when he can make this decision. Another simplification that we just discussed, and back please. Yes, it's how we build the PDAO. So initially, you could do like DAO. You could have in a DAO, just to remind, you can have a number of targets, and then you can have a number of transits. So the target are the final destination, the transits are the parent. So a node, it could have multiple addresses, for instance, and put them all as targets. and he could have a number of parents, and he could all them as transit and just send that to the root, as an example. Or an access router, border router at the edge of the report network could have a number of children which are unaware leaves. And so he would do the DAO for them. So that would be multiple targets, again, all those rules. And he might indicate himself as parent for all of them. So you've got this concept of factorization, multiple targets, potentially even multiple TIOs. And you could even do that multiple times, a sequence of targets and TIOs, and then more targets and more TIOs, etc., etc. So DAO allowed all this complexity. We tried to figure out, how it could work, having too many things in the same PDAO. And for instance, in storing mode PDAO, the PDAO is forwarded across the reverse path from the egress to the ingress. And then the DAO ACK is set by the ingress to the root. So imagine if you wanted to have two paths in the same message, that would be two ACKs from two different egresses that would have to be generated. What happens if half of that works and the other half doesn't work? So it really led to huge complication. So the game here is to say, let's do simple. So we can have multiple targets. Why? Because these are the targets are who you can reach over this track. And to simplify, think of a track as a tunnel, just for a minute. And it's really like unaware leaves. When you look at each time we have to tunnel or we don't have to tunnel, it's exactly the same game. So think about this game, and for a minute, just think that we tunnel all the time. Remember, in user report info, we don't tunnel exactly all the time, but almost all of the time. And see the children and the siblings of the egress of the tunnel as if they were unaware leaves. In a track, you're encapsulated, for instance, to add the source route of a non-storing PDAO. So you encapsulate between the ingress and the egress, and the inside packet goes to a sibling, for instance, of the egress. So you have to signal all those siblings that you can reach over this tunnel. And you have to signal the hops of the tunnel. And you have to give a name to this tunnel. Okay? So what we decided already is that the name of the tunnel is the track ID. It's the local instance ID taken from the namespace of the egress. Okay, so we have this first information that we have to store somewhere, the egress and the local instance ID associated to that egress, which together identify the tunnel, identify the track. Okay, that's one thing we need to signal in this PDAO. Second thing we want to signal in the PDAO is all those siblings and children of the egress that we can reach over this tunnel. But like we said, they must be one hop away, at least when we are doing storing mode. Even in non-storing, but it's a bit more weird. So we need to signal all the siblings. And then we needed to signal the hops, either that ends up as a source route or that ends up as a state in all the hops to go in that direction. We needed to signal this sequence of hops. So the question was, how do we do that? And we tried and we discussed with Raoul, etc. And we ended up with what I'm going to show very soon, which is that we signal the track identification in the DAO. And that's very normal because in the DAO, in the main control message, the base object, you have a DODAG ID and you have an instance ID. That's already there in the DAO. So the PDAO is a DAO, just like the others. But if it's signaling a track, then the DODAG ID is the egress, and the instance ID is a local instance ID that identifies the track. So that was a very, very logical mapping because we are building a DODAG and it's rooted at the egress of the track. So it's completely normal that we signal those things in the DAO message itself. Okay, now could we have multiple targets? Yes, we could. Okay, so because they're all the siblings, so it's not hard to signal the target. So we allow multiple target options. So we call them RTO, ripple target option in acronyms, but the targets. Okay, what becomes of the TIO, which is the transit? Well, remember the transit was just giving you a hop, the parent. But here we are giving a sequence of hops. So TIO could not be used. We have invented the VIO instead. What is a VIO? You can see it as a generalization of the TIO, but with multiple hops in them. So we end up with the same, the PDAO is pretty much like a DAO. You've got the DAO-based object, just that the track is indicated in there as opposed to the main DODAG. Then you have a number of target options, just like in normal DAO. And then you've got a VIO or a source route VIO, which is this VI information option that replaces the TIO. And that instead of having just one parent, it has multiple hops. So it's kind of logical. The one thing that we made as a simplification is to say, hey, we have only one VIO. And there were a number of reasons for that, but just think about the flow in storing mode where the acknowledgement has to come from the ingress. If you have multiple ingress, who sends the acknowledgement? How does that work? What kind of failures should you have to handle? So we said, hey, much simpler. We can have multiple targets, but we just have one VIO. Also, at some point in the past, the source, the storing mode VIO, so the normal VIO, you would basically have one option per hop. So it was a collection of options indicating something serial, but that would consume a lot of bytes. It's actually easier to put them all in a single VIO with a list. So that's a change that I made in the draft. And that enables a better compression with RFC 8138, because that's one of the decisions we made. Now we can compress the VIO with RFC 8138. Can you please go to the next slide, please? So you see, we made a number of simplifications. Now we also made a number of changes that we discussed on the mailing list. First one being to compress the PDAO, because when you have a list of full IPv6 address, that's actually consuming a lot of signaling that has to go from the root to the path. The other reason is if RFC 8138 is enabled in the network, then it's very, very cool that the source route header in the compressed form that has to be added by the ingress to do the encapsulation is already completely built by the root. Remember, in normal operation, only the root builds those source routing header in compressed fashion, because the source routing header always starts at the root in normal operation. And 8138 enables a very efficient compression, but it's more code. It's harder to do. So being able to provide in the PDAO the source route header exactly in the way that it would be put in the packet was a huge simplification for the devices themselves. They just have to pick it from the PDAO, put it in the packet, and there you go. So we wanted to enable that format. And so that was done in the recent publication. Like I said earlier, the Ripple instance ID, the local Ripple instance ID is the track ID. So that's consistent with, like I said, 60-ish and row. So all those drafts, all those works are expected to be done that way. What is a bit harder is if it's a local instance ID, it's always associated to an IPv6 address, because the IPv6 address is the namespace for which this local instance ID is taken. So you always need to have both in the packets. So in Ripple, that was already specified like this. You need to say if the source of the packet or the destination of the packet is the namespace. And so there is a bit in the local instance ID in the RPI to tell you if the namespace associated to that local instance ID is the source of the packet or the destination of the packet. In the case of a track, the track is directional. It's always going towards the egress. So the namespace is always the destination of the packet. And so the flag that indicates source or destination is always on. It means destination. So basically in this draft, we say, hey, when you write a track ID, you have to have the bit always set. So there are not two versions of track ID, the one that would just not specify the bit and the one which has the bit set, which goes in the packets. So let's always set the bit. So there is text now to say that. The complication that goes with that is when you have a packet and you use the non-storing mode, so you use the routing header, the actual destination of the packet is at the end of the routing header. It's not the destination in the IPv6 header itself, because you have to consume all the routing headers until, and when everything is consumed, then it's actually in the IPv6 header. Otherwise, it's in the routing header. So it's kind of hard in the normal IPv6 formats to find who is the final destination. You have to look at whether the routing header is consumed or not. If it's not consumed, then it's the last hop, the last entry routing header. If the routing header is consumed, then it's the destination, the IP. Wow. So I had to write text to explain that. So I did. But if you're using 8138, 8138 made it so that we actually encode the destination in the IP header as the first entry in the routing header. So everything is in the routing header. And that also makes it so that the last entry in the routing header is always the final destination. There is never a question. So 8138 is really meant to make the forwarding much simpler. Well, that also makes this particular operation of identifying the namespace of the track ID a lot easier. So if we have 8138, it's easy. If we don't have 8138, you have to look at whether the routing header is present. If it's present, whether it's consumed, and blah, blah, blah. Okay, one addition we made recently, but I kept it on this slide, is that we have added this sibling information. So in addition to the normal DAO signaling from non-storing mode, the sibling information gives the root all the topological information that it needs to build the structs. Now, what is not done in the draft, and I don't think we should do it, but if you tell me do it, we'll do it. It's that we don't say which sibling a node should advertise. Because in a very dense networks, you may have hundreds of nodes around you that you could signal. That would be a lot to signal to the root. So you may have to decide which siblings are useful and should be signaled to the root and which ones should be ignored. For instance, because they don't give it in that direction, you have enough siblings to progress. You don't need more siblings in that direction to go to somewhere. And I don't know that. So the reason why you should signal siblings and which siblings you should signal in this sibling option, we don't have text for that. We don't explain, it's out of scope. Sibling selection is something else. So if you have very few siblings, an implementation can just signal everything and we are happy. If we have a dense situation, there will have to be some intelligence to decide which siblings to signal, and that may depend on the use case. It's out of scope. Next slide, please. And Ines, you interrupt me if you think I'm taking too much time, because like I said in the bashing, I need more time than 15, but when you think that you need the rest of the time, just cut me.
Okay, thank you.
So we have that requirement on the mailing list, and I heard it again recently from another source. It's useful to be able to ask for PDAO from within the network. An example of that is if you look at the TSN architecture. So and I don't have a drawing for that, so you have to bear with me. There are 3 modes in the TSN architecture. The first mode is you have an application controller talking to the network controller, and the application controller tells network controller build this path. So there is no interaction between the node that generates the packet and the deterministic tunnel, if you like. It's all happening between the controllers. So the node may talk to its controller, say I need this path. The application controller talks to the network controller, say I need this path. The application controller talks to the network devices, so that's the PDAOs, to build the path. And when the path is built, the acknowledgement goes back to the PDAO app, goes to the root, and the root talks to the PC, which is network controller, and says, I'm happy. The network controller goes to the application controller, say, I'm happy. And that goes back to the node which needs it, that can start the traffic. So there is no interaction between the device and the network. There is no UNI. The second model is completely the opposite. It's completely distributed. It's when something like RSVP happens in the network and there is no control at all. So it's a model that's possible, but it's not one that we support with .NET or TSN really now. We go to controller based, at least for the network. Now there is a hybrid model where you have a UNI, user to network interface, between the device and the first hop router, something like what we do with World, for instance, with 8505. So you have like an ND abstraction between the host and the network. And then the network goes to the root and say, oh, I have this request to build this track. So it's really a request coming from a router in the network, which says, I need to build a track to that destination. And so with just PDAO, we did not have the signaling for saying this. So we added this PDAO request message and this PDAO acknowledgement message, this PDR acknowledgement message, which basically enable a router to go to any router in the report domain, in the DODAG, to go to its root and say, I need a destination to this particular target. And the goal is that from there, the root, that PDAO creates the track, can be a multi-segment track, can be a complex track, comes back and say, I built it. And then over the UNI, the first router can go and tell the guy, hey, yes, now the track is ready. You can start sending me packets. One remark is inside this PDR and in the PDR acknowledgement, you have the track ID that is present. So it's the same locally significant instance ID for the egress of the track. When the requester makes the request for the first time, it does not even know who the egress is. It just knows the target. So it would put zeros to signify, to indicate the egress and to indicate the instance ID. So everything that identifies the track. But there will be a time where the lifetime that was requested for this track is exhausted, and when it will need to know. So in the first request, it's all 0. The PDR rack comes back if it's a status 0, saying okay. It will come back with the egress IPv6 address and the local instance ID. So everything to identify the track. And then if the ingress needs to continue, maintain that track beyond the lifetime, then it will use that information to renew, basically. So it's not a big surprise. The thing that's more interesting is that the PDAO and the lifetime of the segments in the PDAO is completely separate from the lifetime of the track, meaning that say it's a simple tunnel multi-hop segment, just one segment, source to destination, and that's the track, a serial track. So say you're building that, you may say, so the PDR may say, I want it for an hour. And that's the track lifetime in the PDR, the PDAO request. Well, the root may send a PDAO of 10 minutes. And after 10 minutes, a new one, after 10 minutes, a new one, and maintain that at a completely different time scale as the track. So the PDAO lifetime, so the segment lifetime in the PDAO doesn't have to be the segment, the track lifetime at all. They're completely decoupled. The PDR is a contract between the requester, so the ingress of the track, and the root to get a track for a duration. How the track is managed by the root is orthogonal. The timelines don't have to be aligned. So there is a lifetime in the PDAO, there is a lifetime in the PDR. They are not the same. So as we said, the mailing list, we aligned the wording for track. And I have issues that are tickets that are raised for the security section. I know I still have to handle them, but right now we're handling the main operation. When we know what the main operation is, we can look at the security issues with them. Yeah, so I did not do improvements in the security section right now. Next slide, please. Okay, so this illustrates what I just discussed earlier. So what you look at, if instead of track ID, you have instance ID, and if instead of IPv6 address of the track egress, you have DODAG ID, guess what? It's exactly the DAO as in RFC 6550. So we're just saying, hey, a PDAO is a DAO, same format, same information. The IPv6 of the address of the track egress is the DODAG ID of the track. And the track ID is actually a local instance ID, so it's an instance ID, it's conforming. Next slide, please. Yes. Okay, so this draft introduced the VIO and the SRVIO as with a generic name of route projection options, which replaced the TIO basically when instead of having just one parent, you have this multi-hop path to get to the target. So here is the format of the VIO. It has evolved many times. So here is the latest. So what we basically said is this VIO is a segment within a track. We also said that the track identification is not in the VIO because it's in the DAO that we just saw in the previous slide. So we don't have to identify the track, we just have to identify the segment. The segment can be the full track if it's a serial A, B, C, D, but it can be just one, I would say, edge in a graph to get there, if the track is a complex track. So what we need is a segment ID because it will be refreshed individually. So each segment of the track has a PDAO separate, and it's refreshed separately. So it has its own ID. One segment may be killed and replaced by another segment, and the rest of the track could stay the same. So they are completely managed individually. They have a sequence in the lifetime like everything repo. So this is not very surprising. So it's the same kind of sequence as we had in the TIO. And then what you see is an SRH 6LoRH header because we enabled 8138 compression. Now, if you don't want the VIA addresses, the hops, to be compressed at all, well, 6LoRH has a format for that. You just use a type 4, and that's basically the full address. But then if you use another type, they're going to be compressed. In the case where you have 8138 enabled in the network, and you're using non-storing mode, so you put a routing header in the packets, you encapsulate with a routing header. What we want is what you see here, as I said earlier, to be exactly what goes in the packet. It might be that you need more than one SRH 6LoRH if the size of the compression changes along the path. So in that case, you need to have multiple actually SRH 6LoRH in there. I just show one, but it could have to be repeated in that particular case. So imagine that after the VIA address N, you can have another SRH 6LoRH header, more addresses, then another SRH 6LoRH header, and more addresses. Could be in the case where 8138 is enabled in the network, and we are using non-storing PDAO. Next slide. Okay, so that's a reminder of REPL, because REPL is already like that. When you have a packet that flows in the network, the final destination of the IPv6 header or the source is the namespace for a local instance. The instance itself is signaled in the RPI, and it has basically, if it's a local instance, you have one bit which says local, the first bit must be set, then one bit which says source or destination. And like I said earlier, when it is set, it indicates that the namespace is the destination. And then left are 6 bits for the local instance ID. That's why you can have at most 64 local instances, so 64 tracks that terminates at the same egress. But for each node in the network, you can have 64 tracks that terminate in this node. So that gives us quite a bit of signaling space. Next slide. So here is the look and feel of the new sibling information. I had a question about step of rank. I think I did it, but I forgot. Yes, somebody wants to speak? Okay, so basically you have the address of the sibling and the cost from the node to the sibling expressed as a step of rank. That's pretty much it. Next slide. So here is the PDR. Don't be surprised, there is a lifetime, which is the duration for which the track should be built. And if we want to make it longer, we have to set a new PDR with the track ID that we get the first time. So the first time the track ID is set to 0. Next slide. And here is the PDR hack. What doesn't show here is in both cases, we need the track egress. So it should be present all the time. So I need to add it. Next slide. And here are the padding issues, and we are getting close to the end of this presentation. So the first big padding issue is how do we have to place the egress of the track in the sequence of hops in the VIO? Remember, the egress is already signaled in the PDAO base object. On the other hand, if you want to use 8138 compression and you want the root to build the full header, then you would like to put the egress in there because it's the last hop, it's present in the header. There are other reasons as well for which you would like to place the egress in the sequence. For instance, if you're changing the main instance as opposed to building a track, in the case of the main instance, you need to know the last hop because the geodag ID is the main geodag ID. So you don't have to signal a geodag ID because it's a global instance. There is no geodag, there is no namespace associated to it. It's just a global namespace. So we don't place the geodag ID in the DAO, and so it has to be indicated in the sequence. So overall, there are many cases where you want the egress to be indicated in the VIO. But then it's kind of a duplication with the fact that in some cases it's also in the DAO. So do we want a simplification that it might be duplicate information? Or do we want to have a lot of complexity saying, hey, in some cases it's placed, in some cases it's not. If it's not, you have to put it yourself because at the end it has to be there. So then that's really a question to the group and to you guys. I mean, do you want to aim for simplification in this case? The cost being that we might, in some cases, duplicate the egress node, one in the DAO, and second, as the last entry in the SRVIO, in a compressed form. It's okay to do that, or do we have to go through the complexity? I'm not sharing anything.
From my side, Pascal, and I'm still not sure as in why why the last the egress address should be present as the last element in SRVIO. You know, so
let me explain that again. Okay, so first case is you're in the main instance, right? So in the main instance, you don't signal the DODAG ID in the DAO because that would be the root anyway. Right.
Okay.
So even if you signal it, it's the wrong thing. Actually, the draft as published says two different things at two different places, and both are wrong. You should not have anything there. Because the DODAG ID is the main, and if you start signaling the track egress there, then it looks like a mess because it's not the DODAG ID of that instance. So it looks weird to try to signal the track egress in the DODAG field of a PDAO for the main instance. That looks weird. If you don't do it there, the only place where you can have it is the last entry of the segment in the VIO, the last in the VIO that expresses the segment. In that case, you must do it. Now, the other case is, so you have 8138 deployed, right? So you're running the compression. And as I said earlier, I made every effort so that the SRVIO, which has the source route header built by the root, is built exactly like you would like to see it in the packet. So the node just have to pick it up there, put it in the encapsulation after the IP and IP. Just go for it. Don't have to do complex computation of doing the compression himself, right? The compression is done by the root. But the format that you have has to include the egress. You have to remember the way 8138 works, but each entry in the routing header depends on the previous entry. You build on the previous entry and you just express the change. So basically, the node would have to understand exactly the compression that took place all the way to the previous hop, to the penultimate hop, before to know how it can express the egress as an addition to that. So that makes his life complicated. So that's the second big reason.
So Pascal, now I think I get a hang, but I think I'll have to revisit 8138 again to understand that point more clearly as to what you're saying is that the compression depends on the uncompression depends on having that last element present there.
Yes,
right?
it's a bit like co-op when you build the next option number as a delta to the previous. So it's kind of like that. If you know the previous address, and the routing header will tell you how many bytes differ, and you just override those bytes. Now, if for instance the egress differs by only 2 bytes from the penultimate hop, then you need a 6-layer SRH which expresses 2 bytes. Now, say for some reason that the previous node has a 6-layer SRH that uses 4 bytes, then you need to insert an additional 6-layer SRH just to say, oh, now 2 bytes. On the other hand, if it was already 2 bytes, then you can just put one more address in there. So just doing the computation of how to add something basically brings you to have to understand all the complexity of how you encode a 6-layer RH in the first place, which is complex. And right now in REPL, the node don't have to do that. They have to be able to read them, but they don't have to be able to write them. And I wanted to keep that simplicity where the node, even if they are the ingress now of a track where they have to do this encapsulation and place the routing header, they just have to memory copy, mem-copy from here. You know, just exactly those bytes, bang, you're done. And those bytes being built by the root. So we don't have to look at one implementation which doesn't know how to build it correctly. It's always the root.
Okay. Pascal, another question I have is in context to the siblings information. So in one case, at one point you mentioned that let's keep the calculation of the quality of link to the sibling. That calculation is an OF type calculation, and we'll keep it outside the scope of this document. But at the same time, we are introducing the sibling options, the new option to specify all the siblings for this node.
Can we go back, please, to the Raoul, I'm sorry, just so that,
Yeah.
yes, exactly. Back to the sibling option, please, Ines.
Yeah,
There we go. Yep.
Yeah, so here, so one thing that you mentioned in during your presentation is that the calculation, the quality of link from the node, from the egress node to its sibling is an OF type calculation, and it's clearly out of scope for this document. But in this, so then why do we want to add the sibling information option at all in this document if that is out of scope for that?
Okay.
That
so we have to discuss that on the mailing list, right, Raoul? But the short answer with the current draft is we don't know how the step of rank is computed, but it's present. So the OF is there, right? There might be a different OF for building the track, but then, I don't know. But at least the step of rank for the current OF between this node and the sibling is expressed in here as a step of rank. Now, this is computed with the main DODAG OF. We also have a metric option, which can be placed with the sibling option, the classical Ripple metric option. Okay. If we do that, then we don't even know what the objective function is at the PCE that computes the track. We just know the result of the track. That includes, he has chosen an egress which was near the sibling for a particular OS of his. And the nearness of the selected egress to the sibling would be known because each potential egress sent sibling information with the metric option in there. So like Ripple does, you can put all the metrics, like I read this LQI, I read this whatever. I don't know what you're going to do with that. That's the PC computation, but at least he has the base information for doing his computation.
I'll just like to bring to the notice that the same type of information is required. We discussed that even the NSA extension requires a similar type of information to be sent. So that is sort of an open item for this working group. Yeah.
We if you don't mind, Raoul, let's explain that on the mailing list.
Yeah.
And explain what the premise is and what the relationship with NSA is, etc., etc. But the short answer for this draft is we provide the step of rank for the main OF. So if we're talking about doing something which is as the same objective as the main OF, then use step of rank. If the root uses the computation which is more specific, then we can always, for each sibling relationship, pass the metric information that we already have in normal DAO. So everybody could pass metric informations. And the whichever OF the PC decides to run, as long as the metrics are present in those metric information, it can run. And we don't have to know what it does. It's completely internal to the PC. And then it comes back with a track. That's magic, but we don't have to know. So that's basically where we are with this draft. Next slide, can you go back? I think I'm pretty much done, but is there something else? Yes, that's the missing feature. It's a traditional list of security considerations that I said I did not do. And next step, the workgroup last call around next IETF is certainly not a good idea. We are not there yet. But maybe the one after, if the group helps. So I provided a number of news. I would like to assess if what I presented today people agree with, because there are recent changes which were made or are being made. But if there is something which is wrong, for instance, in the selected simplifications, or if you guys want more simplifications, then yes, feedback on the mailing list, please. And so I have, I keep reading it, but like everything you write, when you read it after, you miss the bugs. There are still a number of bugs, including the DODAG ID of the main DODAG, which should not be there. And there is things which appear several times and not necessarily consistent I need to fix. So there is some editorial work, but I have the feeling that we are converging on the main operation. So that's my feeling with this draft. We are getting there. Need cleanup, need simplification. If you can have ideas of more simplification, need some text messaging to remove duplication, remove some bugs. Getting there. That's pretty much how I feel about it. And that's it, I guess, this time.
Okay, so let me begin.
Okay.
All right.
Thank you very much, Al, for your information. Do you are aware of some implementation of things?
We are starting to implement it. I think as a prototype, but you know the draft is still in flux. So obviously we don't have a final implementation of the draft, which is not final. But yes, on our side, we are beginning an implementation, I would say. We have one person assigned, and you know, when he can, he goes and do some code. But you've seen the draft, right? I mean, I've published like 3 versions, 3 upgrades. We've had a number of discussion on the mailing list. Each time, you know, the formats change and blah, and the restrictions change. So it's not like we are doing a product tomorrow.
Okay. Thank you very much, Pascal. More questions? Okay. Raul, please.
Okay, I'll just the capabilities draft. It has. So can you go to the next slide, please? We had got received feedback from Dominic on the GitHub repo, and we have made changes. Let me just clarify here that there were no changes which impacted the basic structuring of any of the options, or there was no major design change as such in the document. But thank you, Dominic. We have received an elaborate review of the complete document. The changes are already pushed in. Another aspect is Ines listed some of the open items during the beginning of this meeting. Those open items are already taken care of, especially in context to the capabilities draft, in context to the observations draft. Some of the items are open. So let me just summarize what the document contains currently. It contains the capability options that can be carried as part of our REPL messages. How do you advertise the capabilities? So it's a new type, it's a new control option. Then we needed some instantiations of existing capabilities. So we have two types of capabilities right now there. The one is the capability indicator flags. For any capability which just can be signaled using a simple flag, and then there are more verbose capabilities which requires some sort of additional information to be sent. So currently we have the indicators flags and the routing resource capabilities. In the last version, we even had something called as neighbor table capability, which basically signaled the NCE, the amount of information, the amount of entries that can be part of NCE. We have removed that because we didn't have any specific use case in mind right now. Then the next thing that we have in the document is the query and response signaling. This was already discussed in the last interim, in the last IETF session. And then the guidelines for defining new capabilities. The only must that we have in the document is that the handling of capability is mandatorily required if the network uses MOPX, basically MOP greater than or equal to 7. Next slide, please. So these are the capability options. So there is one container option called as the capabilities option, which can contain multiple capability TLVs. There are 2 TLVs currently defined: the capability indicators and routing resource TLVs. And then there is another option which is specifically used in context to query and response, which is the capability type list, which will, in using that option, it is possible to enumerate all the capabilities that are supported by that particular node. These are the only 3 things that have been introduced by this draft. Next slide, please. This is the basic signaling that we have for query response. There are some cases which has some detailed information, as in if there is. So the first diagram is about querying the supported capability types. Like I mentioned in the previous slide, there is a capability type list option which can be responded with. It is also possible for a node to query for specific capabilities, where the cap1 and cap2 is present. In the second diagram, you can see that the root is querying whether cap1 and cap2 is supported by the target node. The node sends back the capability, the corresponding capabilities with the corresponding values. Now, it is possible that only the partial list is supported. For the query is made for cap1 and cap2, but only cap1 is supported. So the draft has handling for that as well. And there are corresponding secure messages for this query and response messages as well, the capq and capS messages. So that's next slide, please. So that's pretty much it. From the capability side, we didn't had any major update since, and whatever work items we envisioned before starting this work has been fulfilled. So I would like to see if there are any specific opinions as to how we can proceed with this draft. From my side, there are no further updates that are pending. Can we get can I make a request to this working group to get some reviews done?
I have a question, if
yes,
possible.
Yeah.
Okay. Well, the question is not really to the draft itself.
Mm-hmm.
And yes, I hope you review, Raul, by the way. The question is more like for REPL v2, so it's going to be just put on the table now, but we have this REPL v2 discussion. Shall we continue to maintain all the secured version of the options and all the support of security that was inside REPL v1 that nobody ever implemented? As I know. I mean, maybe somebody did, but I'm not aware of any implementation of the secured version of REPL. As it goes, this and the fan-out control bits or the other bits in the configuration option, the DODA configuration option, that we may want to clear after MOP7. The change that we do for use of REPL info says basically that the configuration flags are not defined after MOP6. It renames the registry to say for MOP06, meaning this byte of flags does not exist in MOP7. So that really reopens the question of supporting the security version. And so I would like, before we because we do this work for REPL v2, and if somewhere else we decide that REPL v2 doesn't have the secured option and doesn't have the fan-out control, then this draft should not even worry about it. That's what I mean.
Pascal, just one clarification. When you say the fan-out, you're talking about the path control bits. Is that correct? The path control bits.
This is correct, Raul. The path control bits are managing how many copies of a DAO can flow over the reverse DODA to the root. Yeah. So that's the fan out, how much it spreads.
Okay. Yeah, so that's but one thing is, if we decide to not have a secure message for any of the existing message, then it basically means that the secure RPL will be broken. So if that is okay for the working group, we don't have any implementation. Yeah,
it's more like when we specify what REPL v2 is. Will we specify REPL v2 with every feature of REPL v1, or shall we drop the features that nobody ever cared for?
Okay.
And this security.
But I think the immediate question is whether or not this cap Q, cap S needs a secure value, secure version, I think is what the question was.
Points to that, right? I mean, do we need to keep adding secured version of everything we do for Ripple v2?
So Michael, I don't believe the question was in context to capabilities per se, because in my we haven't envisioned using CapQ and CapS in secure messages myself, but
well, I agree. So but I think the point was, do we just define any new message as also having a secure version? Is the point. Is that because the registry is not arranged that way? It actually is arranged. You could actually create secure messages that don't have unsecure ones, and vice versa. The registry isn't say it's just this bit. It doesn't say there's this upper bit and then a 7-bit value. It says there's 256 things, some of which are secure and some of which aren't. So we could not bother defining it in a secure form because of the reasons Pascal gave that we're probably going to rip them out.
Okay.
I would be fine with that. It's unfortunate that no one has found a business case for the secure version of Ripple. But that's it as it is.
Okay, but from the maintenance side, it's not a big change to keeping the secure version of the corresponding messages. In a way, the high order bit,
yeah, it's not a big deal. It's just an entry.
Yeah. Sorry. So another thing that you mentioned, Michael, was we don't have a mandate. The RPL doesn't mandate that for every message you need to have a corresponding secure message, but in a way, the way message the message type is decided. For example, it's 0x01 for DIO. It's assumed that 0x81 is for secure DIO. So that one-to-one mapping is in some way it is there. We might want to. Okay.
We get Alvaro's, and yes, we need to bring that to the mailing list. We'll start discussing it right after, but yes, certainly.
Yeah, sure. Okay. Let me go on to the other slides. I just have a couple of more slides to talk about. And again, Ines, can we please go to the next slide? The MOPEX updates. So MOPEX, the primary update has been extending. So there is earlier the draft only talked about extending, adding an MOPEX option. Basically, the base MOP, if it is 7, how would the extended option looks like? The new MOPEX option looks like. But in the last version, we added something called as extending RPL control options in a way in which it could be backward compatible. The new options that we keep adding, and we are adding new control options at a very great pace, even in the DAO projection, even in the capabilities options. We want to make sure that we have a good system, especially if anyone decides to add a new control option to keep it backward compatible in a proper way. So this particular RPL control options make sure that we can have backward compatible RPL option format. That's it. The only problem, the one problem in the last version was that the location of X bit was assumed to be second most MSB. The assumption was that the first bit was used for secure control option, but there's no such thing as secure control option. So we moved the MSB to the first. We now started making use of the X bit as the first MSB. The INI section is updated to reflect all these changes because this is an update to RFC 6550. Yeah, that's it. I guess. Can you please go to the next slide, Ines? Yeah.
Thank you very much, Raul. Yeah, we will request a comment for both of these documents. And so from Ripple version 2 topics, we need to prepare the contents. But yeah, I think before going too deep in that, we need to solve the projection issues, capability and MOPEX as well. So how to think that we'll proceed. We need to prepare the table of content and put topics, and then figure out as well what about the secure messages version. So, um, do you want? Do you have some comments on that? We have already the table of content in GitHub, so you can update it. But I think as well it's important to solve the current draft that the working group has. Like, well, now we are having aligned the use of REPL info and our leave, compression, turn on. But as well, we need to figure out as well what to do with the softwares like the projections and the rest that we have as related documents, and at the same time we can work in the table of content and define which section of the RFC 6550 are going to be modified, extended, or deleted from this version. Do you have some additional comments on it? Probably, okay, probably it's going to be as well this topic, the main topic for the IETF 109.
There is utilizing the IO information.
Yes.
Yes.
Sorry? Yes. Yes. Please proceed.
Oh, yeah. So basically, one thing here from this list is that PDAO and AODV repo are kind of things we do for REPL v1 as well, right? They are defined in the REPL v1 world and would be ported in the REPL v2 world. But the question I had on secured options applies to PDAO as well, because we have this the PDR and the PDR hack probably will require a secured version. And
yes.
Unless perhaps the group tells me, not to write them, I will have to take my pen and emulate what we do for secure option, even if I know nobody will ever implement it, which is kind of a pain. I just did not want Raoul to go through that same pain if we decide that for REPL v2 we don't do that. Right? That's kind of what the back of my mind when I discuss that.
So yes.
So PDAO and AODV repo could need some porting here, but they are repo v1 functions. MAPEX, etc. They are pure repo v2 functions. So that's how it looks strange on the same list.
As well, they are. I don't remember which part, but in 6550 there are some kind of section that say this is for future work, this part is for future work, and this is for future work. So we will have to check which kind of this future work that 6550 was mentioned can be applied here now. I don't recall exactly which sections, but I will check that. As well, I think we have to do like a priority list. What issues have to be solved before we can proceed with that? But I mean, nothing avoid to work in the table of content and update the GitHub with the topics or make a draft on that. But you feel more comfortable. But I think we need to the priority list to issue solve to start working on that. What do you think?
Certainly. So my message was for your list, maybe split it in like new functions. That's things like MOPEX, etc., or elide via your information. There are functions which are ported from V1, and that includes PDAO, repo, IODV repo, and functions that we keep from REPL v1 when we go through the document. And there are probably the missing extensions or the refinement of v1, where we said, like you said, this is for future, or we said, we don't know exactly how this is done, so we leave it to implementations, and maybe somebody will define that in the future as part of repo. So there are things like, how do you know your neighbors? We say, oh, it could be NDE, blah. So some things are not really defined, the use of stretch, things like that. So a better definition of things which were left a bit to implementation in Repo V1. That would be the third category, and that includes what you said, like left for the future.
Yeah, and as well, we have to identify, how would say, which part of the 6550 get obsolete with this new version, and put it like, please pay attention that these kind of things are obsolete. This kind of thing, why, the reason why, because we get this improvement. So, yeah, we can start working on that. Thank you. Additional comments? What do you think is the way of working? The GitHub is okay for you? Start putting there, or a draft.
Yeah, I don't know if it's an official policy, Ines, but it looks like it is almost official. Is every workgroup document should be in the raw GitLab.
Yeah, exactly. Yeah, the same. So so action points like identify from 6550 which sections are specified as a future work, and just add it to the list, and then set the priority issue that have to be solved before we can proceed with this RPL2 version 2 topics. So do you agree with these action points? Or how? Okay, great. Thank you.
Can you state the action point again? So I can
sorry.
make note of it, please?
I don't know. Yes. The action will be like going through 6550 and identify the sections that state as a future work, and then add into the list as well, alongside with the priorities issues that have to be solved before we can proceed with these Ripple version 2 topics.
Okay.
And other section, the things that go as well obsolete, and the reason why will be obsolete. So this is, and the information is going to be tracked into the GitHub. There is already a repository for that. Please feel free to add more suggestions. Thank you. Additional comments on it? Okay, I will probably this meeting is recorded. So the IETF secretariat is going to put it into YouTube, and then I will share with you the link. So it's going to be useful to follow the person that could not attend about the new modifications in DAO projections and the modification capabilities as well. So some additional comments or suggestions? We will request a meeting for IETF 109. So please, if you want to present something, we will have time there as well. So, okay.
We have time for any other business or any further discussion.
Yes.
Is there any OAB? AOB?
Okay, so if we don't have none, so I will start the recording now. It's fine. Okay, stopping the recording.